So I'm going to do a little different video just about my 3D printing hobby. I know most people you hear, they get a 3D printer and then they're like, well, what am I going to print? So you go on some websites and you can get things that somebody else made and you can print them out. So this is probably what most people do. So I mean, these are just a couple of things that I got. I'm going to show you just an idea of how I come up with other things to print, because I normally do not download someone else's patterns like this one I just came up with. But I just kind of wanted to make a video because I haven't seen any out on just kind of a prototyping beginning to end on using a 3D printer, at least the way I do it. So simple. I was having a problem with this spool, which I know a lot of people with the printer, especially this printer. It's a very popular one. As it's pulling on here, it was snapping my filament and it was kind of getting stuck. And the original, this is the original arm, just went up here like that. And the spool sat on this, but this doesn't turn. So I've seen some designs where they put a bearing in here, but it's still not the size of the spool. So I ordered this one because it's made of aluminum. It was really nice. It has ball bearing rollers, and see how they're angled. So what this should do is it should sit in here, and when you tighten this down, see, like it would go on the other side of this, and as you tighten this down, it would center it and pinch this and then sit on the roller. So this would roll really smooth. But I ran into a problem. Some spools have this size, which this works perfect for. And then some spools have this size hub, and it falls right through. So I got online to see what other people are doing, and that's when I came up with, like, this are a few other ideas. This one would just be an adapter that go in, but see, it's all loose. It would still shake around in there. And then I found, like, this one, it's more like a spring, but it falls right through. So I know you could just upsize this, like if you wanted to go on the software, you could say print it at 110%. And then it would probably fit in here nice and tight, not just fall in. But what I didn't like is, I don't know if you could see this. See right here, that tiny little tab on the end of this? That's all that's supposed to be hooking this side so it doesn't fall in. So I'm like, why didn't whoever designed this make it bigger? I don't know. Also, when you get to that size, see how small that center hub is? Now this doesn't fall in here anymore. So you're just running into a different problem. See, it doesn't fit in here anymore. So now you would just be pinching it and it wouldn't like fix the problem. So I looked around for a while at just something already done, because if there's something already done, I want to do that. I don't want to work harder. But so kind of what I need is this. I want this, but I want this angled right here, like tapered. So as it goes in to the big spool, it's going to auto center itself because it's a cone. Okay. And then this center hole, since I want to use this aluminum thing I paid for and the bearing, I want that exact cutout in the back of this right here. So this pops in. So obviously, like, I haven't found anything. I don't think anybody's going to have exactly what I want. So I'm just going to show you how I'm just going to go make it. And then we'll come down and we'll print it out. And you'll just see kind of an entire step-by-step how you just make something from scratch. The first thing we're going to do is just measure the part. We're trying to make kind of this part and this part to fit in it. we're going to be using Fusion 360. I've only been using it for a couple of weeks. I'm not a pro, but I think that's the good part about showing you is how easy it is to learn. That if you want to make your own parts, just download it, use it, watch some YouTube videos, learn how to use it. And you know, you'll pick it up quick if you actually want to. So I wrote down some of these measurements real quick. We're doing millimeters. So it's about 86, this part. And I was thinking I want mine maybe a little bit bigger. So I went with 95. The outside of the part we're gonna make is gonna be about that much bigger. So, you know, 95 millimeters, just a little bit bigger on each side. The inside cone, if you're looking here, the inside of this is about 72 millimeters. So I'm going to want something a little bit bigger so it doesn't fall into the hole. So I went with 75. So our part is going to start 95, then this bottom ridge is going to go to 75, and then we're going to taper that cone up. 2 of these have to go in here, and you don't want them to run into each other. So we can't make this taller than half of this. So right here, ours is about, I would say about 60, 59.9. It's about 60 millimeters wide. So we're not gonna be able to make this more than 30. So let's just do, well, that'd be 30 including this. So we can do 30 up to here. So let's make our total height 30. Let's write that down. So it's gonna be 30 millimeters tall. The center hole, I was thinking we'll make just about the size of this hole so it doesn't get into anything. So I put 18 and a half, 18.8 is exact. So 18 and a half is going to be our center hole. And then if you look at this part, it tapers down here and it kind of has a center circle. So if you measure the center circle, it's about 33.8 millimeters. Sorry, the dogs are running around. So I'm going to do mine 35 because the worst thing we can do is make this exact. The printer's a little bit off and then it won't fit. So we're just going to make this a little bigger. The next thing is the distance from top to bottom. And if you look at the distance top to bottom, it's 69.25. So we're going to do probably 70. That'll give it just a little bit of play. Maybe we'll go 70.5. 70.5. All right, so that's our measurements. And the next thing I'm going to do is just show you, I'm sure there's people much better, but I'm going to show you on Fusion at least how I would do it. Okay, so there's a lot of better videos probably on how to use Fusion, so this is not one of those. I'm just going to show you how I use it, and I only learned by watching YouTube. So what we're going to do is first start a sketch. We're going to pick a plane. We're going to make a circle, and based off of our measurements, we know the first circle is going to be 95 millimeters. And we wanted it, this flange right here, we wanted it about 5 millimeters tall. So we're going to extrude this, and we're going to go 5 millimeters. So now we have our first part, right? That's going to be the flange. Now we're going to create a sketch on that flange. And we're going to do this, next we're going to build the cone, okay? We knew that we wanted about 75. So we're going to draw a circle from here, and we're going to go 75 millimeters. And then we're going to extrude that with, we wanted a total height of 30, right? So we're going to 30 plus the 25, or plus the 5 millimeter flange. So we'll do it 25 here. So the total height will be 30. I want to chamfer this. So we're going to go in here and we're just going to chamfer the top edge. And we know this is 25 millimeters tall. So we're just going to chamfer this 25. And then we're going to draw another sketch right here on this top face. And we knew the center hole we were going to do 18.5. We wrote it down right there, 18.5. And then we're going to extrude this too. This time instead of up, we're going to cut it distance to the whole object. So now we have a hole down the center of our part. So that's basically done now. That's what we wanted. That's going to be this in a cone shape. That'll fit any one of these size spools. Now if we have a big spool, it'll center. Or if you have a small spool, it's going to fit. Now, the more difficult part is we're going to flip it to the bottom, and we're going to basically make this inside of that part. So we're going to draw another circle. Let's sketch on this plane. We're going to draw a circle from the middle. We're going to come out. We said this right here, we were going 35 millimeters. So we're going to come out 35, and then I'm going to draw another circle at the total diameter at 70.5. So let's do another circle. We're going to come out 70.5. All right. Now we're going to just draw a couple rectangles. So we're going to create rectangle from a center rectangle. We're going to come out here, and we're just going to meet it up here. So it doesn't have, this part doesn't have to be exact because we're going to put in the measurements, the exact measurements we want. We're going to do that one, and then we're going to come out here. And all I'm doing is making a tangent from this circle to wherever it snaps, because it's automatically going to snap when you hit it. So right there. So this is basically now, we just made this. But what we're going to do is, we need to know this. This is 16 millimeters. We're going to go a little bit bigger. We're going to 17 millimeters. So we're going to hit dimension here, and we're going to do 17 here. This one's also going to be 17. Okay, so now you see I made these sizes the right size, 17 millimeters, but these sizes are too small now. They should be all the way out to this circle. So we're just going to do this, and we're going to just punch in the size that we think we want. I mean, if I knew the exact measurement, I could do it, but I don't. So we're just going to guess. See how it went kind of past it? Because the 70.5 I punched in was to the center, but since it's a circle, this doesn't come out right. But we're going to fix that in a second. Next thing, we're going to go up here. We're going to do the exact thing, 70.5. And now we have the actual part. Now we're going to go into trim. All you have to do is hit T, and we're going to just trim off all the crap that we don't want. All right, so we're just going to get rid of these, get rid of this part, get rid of this part. Come up here, get rid of this. Get rid of this, this. Just going to get rid of everything that's not the shape that we want. Okay, we don't want this one either. We don't want this top one. We don't want this. We don't even want these center lines. Okay, so now we have the shape of our part. Actually, okay, so now we have our part. What we're going to do is we're going to extrude that part. Actually, there's one more thing. If you look, this has another circle in it. There's this outside circle, and then there's actually the tapered circle. So this tapered one is going to be 48 millimeters. So we're going to take another circle from the middle. We're going to come out 48. So this needs to taper from here to here. All right, so now we have this, but like we have this circle in here, but it's too big here. So we're going to do a little more trimming. We don't want it here, 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 or here. We also want these open inside. We're just going to trim it away. Okay, so now if you look at this, it looks like our part. This is going to be this angle. Everything else is going to get extruded flat. So now we're going to go into the extrusion. We're going to click this and we're going to see how deep into this piece do we want this cut. And it's about 13 millimeters. I don't want it going any deeper to where I have to, like, when I want this out, I got to dig at it. So we're just going to do 13 millimeters in. And you can see it's already cut. If it's up like this, then let me back out so you can see this. If it's up like this, just grab the arrow, push it back down, type in 13, and now we cut it. So now you have this cut out except the chamfered sides. So we're going to go into modify and grab the chamfer tool, and all I want is this edge all the way around. So I'm just going to click on the 4 edges I want chamfered, and we knew we went 13 millimeters down, so we're going to chamfer those 13 millimeters. So now this should be the exact part cut out of the bottom of our cone. Okay, so amazing. We just made a part. We don't actually know if it fits yet, so we're going to print one out and just see if it works. So I'm just going to export this and just call it a cone. And we're going to send it to Cura. There we go. So we're going to put it in here. So we're going to use the Ender 5. We got a 4 millimeter nozzle and we're using PLA. We're just going to do a low quality. We're not making anything that needs to look real nice. 0.28 layer height. Let's see. We're going to go down. Infill, just 20% infill. Print at 200 degrees, bed at 60. 80 millimeters a second. Yeah, why not? Let's see. I mean, it has all my last settings in, so these should be pretty close to what I normally use. Support. It's going to generate support. So now we're going to slice it. I just wanted to make sure that because we have that hollow, that it's going to support that. So we can click preview. It's going to do 107 layers, and then you can break this down on what it's going to look like. So the light blue is our breakaway layers, and it's going to show you every single layer and every single direction of this print. So that's layer 1. The orange is the infill. You can change, like, if these are just a grid pattern, you could make all different kinds of infill. It's going to layer it up. The red is the walls, and that's it. We're done. So it says it's going to take about 3 hours and 48 minutes. If I was trying to do a bunch of them, I might mess with this to make it a little faster, but you know, we're going to do one. So we're going to save it to the removable. Here's a tip that I learned. If you're using the Ender, which is super popular, you're gonna, once you save this, you can't have more than 15 characters. So make sure the title, when you look at it, it's less than 15 characters, or the printer won't show that you have a file saved. It took me a while to figure that out. So if it automatically makes this name, you're going to want to come in here and just rename it. So what I usually do is put, like, what it is, cone, and then I look down here and it's going to take 44 grams of filament. And so I always just put that in the title. That way when I go to print it, I can just look at the spool and I'm like, okay, there's usually a thing right here. You know, that's 200 grams. So you just are going to look at it when you're doing it and make sure you have enough filament when you start. That's it. So then I go in here and I just hit eject, and then that's it. We're ready to go. So next thing, I'll see you downstairs. So we're just going to go print. There's our cone right there. We're going to go print. That's it. So I already have all this set up. So now it's going to start warming the plate. Here's a tip too. I've used all kinds of glue sticks and tape and everything there is. This seems to work the best. From PETG, PLA. I haven't done ABS with it, but I was having a real problem with things sticking. Hairspray and getting a really close Z offset to where that first layer gets squished into the bed. See, there's some hairspray on here right now, but as soon as that dries or this bed heats up, it'll evaporate that real quick. So I think that's at about 3 hours. So in a second, I'm just going to show you what it looks like done. All right, so here's our part. I already broke this out before I realized I should have showed you. This is how it came off the printer with the support material, just like this. I mean, it's an okay print, but we did it on draft quality, so that's about what I would expect. So I popped this out with the little knife, and there we go. That's what we have. And let's see if this fits. I mean, well, that actually fits really tight. It's probably I wouldn't want it any tighter than that. I'm glad we went a little bit bigger on the print. So you see, we went just a little bit bigger. Look at that. I mean, there's no wiggle to this at all. So now that we have our adapter, right, we just made it. Let's see if it'll actually hold that spool. And since I don't have a tripod, I'm just going to hit pause and then put it together. And just like that, it's on. So if you look, I mean, it turned out really, really good. This thing spins so nice, like really free. I'm not worried about this catching anymore. Like, it just seems like the extruder is not going to have any effort pulling this. So what I didn't show you is I printed a second one for this side. So that's that. The second one fit in perfect. This one, and now it automatically centers. There's no play in this because it's a cone. So even if you get different size spools, this is still going to work now. And that's it. Just like that. Just a couple hours ago, we had an idea, and here it is working. Usually it takes me a few extra tries when I'm just prototyping something just to get the sizes right. But I think this is like my 4th or 5th part I've made from scratch. So I think now I'm kind of getting, you know, like how much space to leave. Because if you look, there's like not, you can't even get your fingernail in there on the sides. The top might be a little bit big, and then the sides are, I mean, exact. And I don't think I'd want to get it that exact because most likely it's going to be too tight, and then you're going to be reprinting another part bigger, going back upstairs and remaking it. So, but with enough trial and error, you'll get it down. And I haven't seen a video that was start to finish on just having an idea how to make a part, printing it out, and having it all done. So I hope you enjoyed. I know it's kind of a long, boring video, especially if you're not into 3D printing. And thanks for watching. Bye.